Hi everyone, in this video we are going to look at route maps.
So basically, route maps are complex access lists that allow some conditions to be tested against the packet or route in question using match commands. Okay, so dia macam access list, only is a little bit more complex. So if the conditions match, some actions can be taken to modify attributes of the packet or route. So kat sini lah yang kita bagi action apa yang perlu dibuat dari segi kita nak contohnya nak distribute routes kepada router. And these actions will be specified by using the set commands. So dia ada match dan juga set. Okay, so kalau kita tengok ni dari segi coding dia lebih kurang macam if then else statements. Okay, cuma kita gunakan untuk test against some testing condition mengenai the network. Okay, so kita referkan route map ni menggunakan nama. Okay, so a collection of route map statements that have the same route map name will be considered as one route map. So kalau kita masukkan beberapa statement menggunakan nama yang sama, they will be under the same group lah. Okay, so within a route map, each route map statement is numbered and therefore can be edited individually. So same like ACLs, we use sequence number untuk refer kepada setiap line ataupun setiap entry, ACE entry dalam ACL. Okay, so macam ACL kita ada sama ada name or numbered. So menggunakan name yang sama atau number yang sama, a sequence of ACEs will be under the same ACL. So dalam route map, menggunakan nama yang sama ada setiap number tu akan menjadi statement. Okay, so kita juga akan match mengikut sequence lah, mengikut urutan. Okay, so the statements in a route map correspond to the lines of an access list. Okay, so dia lebih kurang sama konsep dia macam access list. Okay, so bila digunakan, okay, bila route map ni digunakan, so first macam yang kita nak tengok, it is for route filtering during redistribution. We want to select or filter which routes are to be redistributed into another routing protocol. So kita kena match a few statements lah, a few conditions. Okay, so the route maps offer the benefit of manipulating routing metrics through the use of set commands. Okay, so kalau dia match a specific statement, kita boleh set a particular matrix before being redistributed. We can also use route maps for policy-based routing. Okay, so we know that some condition kita nak set, kalau match a certain condition, dia lalu jalan A. Kalau dia match another condition, dia boleh lalu jalan B. Okay, so ini yang kita panggil policy-based routing. So the route maps can be used to match source and destination addresses, protocol types and end user applications. So mengikut keperluan kita punya jenis-jenis traffic. When a match occurs, a set command can be used to define the interface or next hop address to which the packet should be sent. Okay, so kat sini yang kita boleh set jalan mana yang perlu kita forward a certain type of packet. Okay, so in this case, kita apply the route map using the IP policy route map. Okay, so yang ni redistribute, okay, sebab kita nak guna untuk redistribution. Okay, the next one we can use in BGP. Okay, so route maps provide sophisticated manipulation of BGP path attributes. Nanti kita akan belajar BGP and look at all the different attributes for selecting the path. Okay, so kita gunakan command neighbor untuk apply that particular route map. So banyak kegunaan route map ni. One of it is to filter traffic masa kita buat redistribution into the routing protocol. Okay, so the operation adalah macam mana kita nak buat route map ni. First, we define the route map. Okay, and the keyword here adalah route map. And then we define the matching conditions using the match command, and also optionally the action to be taken when each condition is matched. So this is using the set command. Okay, so once kita dah ada all these route map statements, barulah kita decide where to apply the route map. Okay, so which redistribution that we want to apply the route map. So how to define the route map? Keyword dia route map, and then the map tag. Okay, so ni nama lain untuk name lah. Okay, so kita bagi nama kepada route map ni sebagai reference of the group of statements. Kemudian kita ada permit or deny statement, and then the sequence number. Okay, so sequence number ni lebih kurang macam access control list sebab dia akan control the location or the position of the statements. Okay, kat mana? Mengikut urutan sequence number. So ada contoh kat sini. Okay, so route map, nama dia Haga and permit 10. Okay, so to permit a set of routing information lah. So if we match the IP address of a list, okay, 110 ni could be a list, then set the metric of 100. Okay, so set the metric for a particular routing protocol. So permit 10 sequence number ni maksudnya kalau sebelum ni sebelum ada any statements matching the name Haga ni, so this will be the first statement lah. So the first statement match this one and do this one. Okay, set this one. Okay, so ini adalah pertama. So dia akan match yang pertama lah. Okay, so bila kita set the route map, it's important where you want your statements. Okay, so kita nak letak ikut susunan tu. Okay, so the sequence number is important. Kalau kita tak letak, okay, if we do not have the sequence number as part of the route map command. So kalau kita masukkan route map command ni without having a sequence number, what happens? Okay, so if no other entry is already defined with the supplied route map tag, route map dengan nama lah. Contoh tadi route map Haga. Okay, so an entry is created with the sequence number set to 10. Okay, so kat sini membawa maksud the beginning of the sequence adalah 10. So kalau macam statement yang sebelum ni dia letak, okay, so we manually put the sequence number so that we make sure the beginning, this is the first set of statements. Okay, kalau kita tak letak, we just put route map Haga, okay, then the sequence number will be by default put as 10. And then if only one entry is already defined with the supplied route map tag, that entry is the default entry for the route map command, and the sequence number of the entry is unchanged. So kita refer kalau kita tak letak sequence number and dah ada orang define ataupun dah ada definition route map Haga contohnya. Okay, so the beginning yang tadi tu will be 10 lah. Okay, if more than one entry is already defined with the supplied route map tag, an error message is displayed indicating that the sequence number is required. Okay, so nampak error ni melambangkan betapa pentingnya kita tahu which statement yang kita nak masukkan mengikut susunan. Okay, so when dia bagi tahu the sequence number is required, the router wants to know where should we put the set of match or set statements dalam kumpulan route map Haga ni. Contoh lah kan. So kalau dah ada masukkan yang ni, okay, route map Haga and permit 10, and then kamu masukkan match IP address 110, set metric 100, and then kamu guna lagi route map Haga deny, and then you don't use the sequence number, it will ask for a sequence number so that it knows where do we put this next statements. And then bila kamu nak delete, okay, so let's say kamu nak delete certain statement sahaja, tetapi kamu guna no route map tag, and then there is no sequence number. Okay, without the sequence number parameter, then the whole route map will be deleted. Okay, so kena be careful lah if you want to delete the whole thing, okay, dengan sekumpulan statements tu, then use no route map tag. Tapi kalau nak delete a specific entry, then you need to use the sequence number to refer to which entry. Okay. Okay, so next, sama macam access list, there is an implicit deny at the end of the route map. Okay, so the consequence of this deny depend on how the route map is. So the match condition route map configuration command I used to define the conditions to be checked, and the set condition route map configuration commands are used to define the actions to be followed if there is a match, and the action to be taken is permit. So kalau kita tak ada match statements, it will be considered matched. A route map statement without any match statements will be considered matched, and then katalah lepas tu kamu letak a set statement, maksudnya dia match semua lah, dia assume to be match semua, and then dia akan execute the set action. Okay, so ni contoh algo dia lah. Okay, so for example, route map with the map tag of demo, and then you permit 10. So this is the first sequence. You will see all the condition inside the sequence number 10 first. So match XYZ and also match A. So ni condition lah yang kita ada. Okay, kena match dua-dua ni, then do this set of set statements. Buat B, buat C. Okay, kalau tak match, then move on to the sequence number 20. Okay, and then match the condition Q, and if it matches, then set the R statement. Okay, so here we have a sequence number 30 without any statements, then it means set nothing lah. So here, since it's permit, then dia automatically match. There is no match statement. Yang lain selain daripada ni will match but do nothing. Okay, so the reason why kita kata route maps are a complex version of access list adalah sebab dia ada banyak possibility of match conditions and also set statements. Okay, so contohnya we can match the IP address. Okay, so IP address condition pula kita boleh refer kepada access list or prefix list. Okay, so dia macam berganda-ganda lah dia punya condition tu. Okay, we can match the length. Ini bergantung kepada nilai length dalam layer 3. Layer 3 is the IP. Dalam IP header ada satu field bernama length. Then we can also match interface. Okay, so the interface refers to the next hop interface, or match IP next hop. So this next hop will refer to the next router punya interface address. Okay, dan seterusnya lah, match IP source route, match metric, match route type dan sebagainya. So these are all the set actions. So after we match a specific condition, what should we do? Okay, so sama juga sebab dia ada banyak options for us to do the set action. So this is an example. Okay, so I put here the steps, okay, that was in previous slide just as a reference. So here we have the condition yang sebelum ni, contoh lah. Okay, kita ada 4 network daripada the EIGRP domain. However, we only want to redistribute 11 and 12 and set a metric, okay, for only these 2 routes. Okay, so we want to set a particular metric for these 2 routes. So here, the match statement will refer kepada a prefix list. Okay, so we set a prefix list called a filter routes to permit these 2 networks. And then we define a route map, and the map tag or the name is RM into OSPF. Then we do a permit statement. Okay, and permit statement with the sequence number beginning with 10. Okay, so now kita nak tengok what are the condition. So we want to match the IP address. And what are the IP addresses that we should match? The IP addresses will refer to the filter route prefix list. So it should match 11 and 12. Okay, so if they both match, okay, so any routes yang being advertised yang match these two, then set a metric of 25. So we want to set the beginning or the seed metric as cost 25 bila kita redistribute ke dalam OSPF. Okay, and then we want to set the metric type into E1, okay, type 1. Okay, right, so in this case hanya ada satu je lah statement untuk sequence number 10. Then we exit and kita apply kan. Okay, so yang kat sini hanya untuk define baru kita nak define the route map. Okay, and then we apply into the redistribution statement. Okay, so redistribute EIGRP 100 subnets. So this is the regular redistribute statement, and then we put a condition. Okay, so the condition refers to the route map and the name of the route map that we should use. Okay, so that's how we use route map with the redistribution statement. So tadi kita tengok ada contohnya ada 3 possibility of how we want to use the route map. So kalau kita nak guna dengan application lain, contohnya policy based routing, so dia punya command lain lah. Okay, so in this case kita gunakan route map to redistribute our routes. So let's look at how this route map will affect our redistribution process. Okay, kita ada topology yang ni, OSPF area 0 and also EIGRP AS 100. Okay, so kita adalah network ni. Okay, so pay attention to these networks and where they are located. So for router 2 we have 10.2.0.1.2.3. Okay, and then we have 172.16.20 and 21. On the OSPF, on router 3, we have 10.1.0 until 3, and then 10.1.4 until 7. Okay, and then 172.16.0 and 172.16.1. Okay, so let's look at the situation if we apply redistribution without any filtering mechanism. Okay, so katalah tak ada route map, what happens? So this is the redistribute commands without having any filtering. Okay, so for router EIGRP, we want to redistribute OSPF, so we put the seed metric lah. Okay, for OSPF we want to redistribute EIGRP, the condition, so or the statement macam ni lah, redistribute the EIGRP AS number and subnets. Okay, sama juga dengan dekat router 4. Okay, so these are the two ASBR R1 and R4. So when we look at the routing table for router 3 ni yang dalam OSPF domain. Okay, so kita adalah network yang datang daripada router 2 tadi. Okay, so this without any filtering, automatically or by default dia akan set this as external type 2. Okay, so ada 10.2.0 until 3. Okay, and then 172.16.20.21. Okay, so ni directly connected, and then this is the one in router 2 tadi. Okay, now let's look at what happens when we configure redistribution tapi ada filtering. Okay, so we filter using route maps. So this time kita gunakan route map dengan condition dia refer kepada an access list. Okay, so access list 10 permit 10.2.0 0.0.3.255. So dia gunakan summarize lah kan. Okay, so ni slash 3 maksudnya 2 kan. So 2, 6, 8, 16, 22 /22 instead of 24. So dia cover semua yang ada dalam router 2 lah, 10.2.0 until 10.2.3. Okay, so this second access list statement permit 10.1 adalah untuk the one in the OSPF domain. Okay, so in this case /21 instead of /24. Okay, untuk cover 10.1.0 until 10.1.3. Okay, and then we set the route map. Okay, so this one datang daripada OSPF, this one datang dari EIGRP. Okay, so then we have one route map called into OSPF. Okay, and we want to permit, okay, start with a sequence number of 10. Okay, and then match the IP address 10. 10 ni refer kepada a list, and list is the access list 10. Okay, so into OSPF we want to match all the IP addresses networks yang dalam router 2. Okay, then do nothing lah. We just want to permit. Okay, and then we want to do another route map into EIGRP. Okay, and permit 10 also. Okay, ini adalah another route map. Okay, si nama dia lain, and the starting sequence number will be 10. The action will be permit. Untuk into EIGRP, we want to match the IP address that refers to a list called number 20. Okay, so number 20 here adalah the access list number 20. Okay, so untuk ini kita nak masukkan routes, okay, into EIGRP, okay, yang datang daripada OSPF. Okay, so we set a metric for this EIGRP external routes using these numbers. Okay, so yang ni ada match saja, there is no set statement. Yang ini ada set statement ataupun set action. Okay, so kita apply dekat dua-dua lah. Okay, router 1 and router 4. Okay, they are the same. So now we apply the route map into a redistribute statement. Okay, so for into EIGRP, gunalah route map nama into EIGRP. Okay, sebab kita nak redistribute OSPF ke dalam EIGRP. So we use the into EIGRP, and vice versa. Untuk OSPF, we use the route map into OSPF. Okay, so the effect of router 3 will be we only permit those networks sahaja. So tak adalah yang directly connected networks. Okay, refer balik kat topology tu. Ni router 3. Selepas kita buat route filtering using route map, these networks will not be redistributed into the OSPF. Kita hanya redistribute these networks sahaja. Next, kita nak tengok penggunaan route map untuk change administrative distance for certain routes. Okay, so first kita examine the routing table of R1. Okay, so R1 ni the ASBR. Okay, so kita ada satu route being highlighted here, 10.1.4.0. Let's look at where it is. Okay, so 10.1.4 adalah di sini. Okay, and we looked at the routing table of R1. Okay, so 10.1.4. Okay, and the AD is 110, the metric is 75, via 172.16.0.1, the outgoing interface is Ethernet 00. Okay, so ni dekat R1. Okay, so this is R1. Cara nak ke network ini adalah melalui Ethernet 00, and the next hop IP address is 172.16.0.1. Okay, so having the assumption here, kalau kita keluar kat sini, maksudnya dia akan lalu this serial interface untuk sampai ke 10.1.4.0. Okay, so kalau kita tengok sini, ini adalah serial, ini adalah Ethernet. Okay, so sebenarnya there is an alternative way that is faster to reach 10.1.4. Kita boleh lalu sini. Okay, tetapi sekarang router 1 dia memilih jalan ini. Okay, so if we let the router 1 do the decision making, dia akan pilih jalan yang ini. Okay, sebab apa? Kalau kita belajar daripada EIGRP, okay, then bila dia masuk ke OSPF, it will be an external route. Okay, then it will be administrative distance of 170. Kat sini router pilih yang lebih rendah lah, between having learned from EIGRP or having learned from OSPF. So it takes the OSPF. Okay, sebab kalau dia belajar daripada sini, then router 1 ni akan nampak dia sebagai EIGRP external route. Okay, sebab ini 10.1.4 ni datang daripada OSPF. Okay, then dia advertise ke sini ada jalan. So router 1 akan nampak tu sebagai kalau dipelajari ke dalam EIGRP, then it is an external route and the AD will be by default 170. Okay, so dia tak pilih lah between belajar daripada sini dengan daripada sini, which is the internal yang belajar daripada OSPF itself. So dia ambil yang 110. So we want to change how that behavior happens. Kita nak dia lalu jalan yang lebih laju. It's basically we change the AD value. Okay, so kita masukkan ni dalam router EIGRP. Okay, so by default the internal EIGRP AD is 90. The external EIGRP is 170. So we want to change that. Kita jadikan nilai dia lebih rendah daripada OSPF lah. Okay, so the format is the distance and the routing protocol. This is the internal one, kekal 90. This is the external AD. Okay, so the effect will be the routes learned from EIGRP external routes. It comes sebab kita redistribute daripada OSPF into EIGRP, so dia jadi EIGRP external route. Okay, dan since kita dah tukar apa-apa external route, sekarang the AD will be 100. That will be installed in the routing table. Okay, so sekarang R1 kita dah redistribute ke dalam EIGRP daripada OSPF, dan bila kita redistribute saja, tukarkan dia menjadi 100 AD dia. So dalam R1 punya topology table dia dah ada lah. Okay, nak ke network 10.1.4 boleh lalu sini atau lalu sini. Yang ini dah menjadi 110, yang ni dah menjadi 100. Okay, sebenarnya dia datang daripada sini. Okay, tetapi kita set mesti lalu sini. Kan, mesti lalu EIGRP. So dia akan keluar melalui exit interface Ethernet 01. Okay. Okay, next we want to manipulate redistribution using route tag. In this case, kita bagi satu tag. So setiap route yang kita ada, bila dia lalu dekat router tu akan bagi satu tanda lah. Kan, bagi satu tanda. So selepas ni, bila router tu jumpa, dia ni dah lalu dengan tanda apa, contohnya kat sini dia bagi tag 50 kan, then buat sesuatu. Okay, so katalah path atau route tu lalu sini and dia baca tag ni 50, so kita jangan bagi lalu. Okay, so no entry here. Okay, so dia tanda lah sebenarnya datang daripada EIGRP ni, lalu router 4. Okay, and then tag it as 50. So if it goes inside the OSPF and then being redistributed into EIGRP, kita nak tengok boleh tak kita bagi semula. Kan, macam tu. So do not allow entry into the same domain if it is being tagged as number 50. Okay, so tu konsep dia lah. Okay, so dekat R4, okay, we have a route map called EIGRP to OSPF. So we permit and the sequence number is 10. So now kita nak permit semua path daripada EIGRP to OSPF. However, we set a tag of 50. Okay, so remember there is no match statement. Maksudnya automatically it is matched lah. Okay, so set a tag value is 50. Okay, and then we redistribute all the EIGRP networks into the OSPF. Okay, however ada action lah, ada set action. Okay, set action refer kepada EIGRP to SPF. Okay, so hanya ada satu je, sequence number 10, which is set a tag of 50. Okay, so now apa-apa yang daripada EIGRP and is being redistributed into SPF melalui R4, kita dah set dengan tanda lah, a tag called 50. Okay, and then dekat router 1, kita pula buat satu route map, okay, OSPF to EIGRP. Okay, so remember, apa-apa route daripada EIGRP that is being redistributed into SPF melalui R4, kita dah tanda. Okay, so katalah adalah network 10.1.4 kat sini, katalah kan. So nak ke network tu kita dah ada tag. Okay, so kita tak nak routing loop kan, kita tak nak redistribute balik. So kalau dia lalu kat sini, maksudnya router 1 ni dapat this route. Okay, then we want to do something. Okay, and we want to match lah. Okay, ada tak routes yang ditanda nombor 50. Okay, so the route map is called OSPF to EIGRP. However, the action is not permit. The action is deny. Okay, so the sequence number satu je, 10, and buat apa? Mesti match 50. Kalau match, we want to deny. Okay, alright. So yang lain, maksudnya selain daripada 50, okay, exit. Okay, so exit maksudnya tak ada set action, tetapi it is a permit. Okay, so kalau yang ni match 50, then it will stop. Kalau tak ada tag 50, look at the second sequence number 20, then exit, and the action is permit, then it's allowed lah. Okay, so now kita redistribute semua OSPF menggunakan seed matrix ini into EIGRP, tapi ada condition. Okay, kalau 50 deny, yang lain permit. So that's how we use a route map, but in this case we want to set a tag. Okay, so ada banyak lagi kan, kita tengok dia punya match action, match condition dengan set action. However, these two examples are relevant bila kita talk about redistribution. Okay, so in essence, bila buat redistribution, we have to be careful lah. So you have seen the risk. Okay, bila ada situation where we have multiple ASBR ataupun we have something called multi-point, kan, multi-point redistribution. So kena consider one way or two way. Kalau two way, we need to set lah siapa yang hantar apa. Okay, the main point adalah kita nak prevent routing loops. Okay, and you may come across incompatible routing information. So kita kena identify lah, contohnya we want to redistribute, we need to have a seed matrix. Okay, yang lain juga, there may be a possibility of inconsistent convergence time. So you have to set some condition and then do some set action lah. Okay, so here are some options, okay, to prevent any routing issues yang kita dah tengok sebelum ni. Okay, redistribute a default route from the core autonomous system into the edge autonomous system. Okay, so ni guideline lah. So if it's the core, for example dalam OSPF kita ada area 0, so we redistribute a default route. Okay, and redistribute routes from the edge routing protocols into the core routing protocols. Then redistribute multiple static routes about the core autonomous system networks into the edge autonomous system, and redistribute routes from the edge routing protocol into the core routing protocol. So if you look at these two, okay, so basically the edge ni maksudnya yang ASBR lah, kan. So ASBR kita redistribute static and default route. So route yang lain tu selalunya datang daripada yang contoh topologi dia macam ni kan. So we just want to distribute these, okay, yang bukan berada di edge ni. Okay, So kalau dekat edge ni, untuk jalan nak ke sebelah, kita provide default and static routes. Next, redistribute routes from the core autonomous system into the edge autonomous system with filtering. Okay, so ini yang kita belajar tadi lah. Basically, we want to do some filtering. We want to be careful with what are the routes that is being redistributed. Okay, so we want to block out inappropriate routes. So yang ini jalan dia kalau nak redistribute, we need to do a static or a default route. Okay. Okay, next we want to make sure that the path is optimal. Okay, so modify the administrative distance with redistribute routes so that they are not the selected routes when multiple routes exist for the same destination. Okay, so kita tengok dah contoh tadi how to modify the AD and what was the need kan. Okay, contoh yang macam ni. So we need to modify lah. So be wary of when we redistribute what will be the effect. Okay, so that's it for route map.